Good morning. This is Paresh Parmar, Assistant Editor of Foundry Review, your host for the day. I'm delighted to welcome you all to MMR Events annual seminar Casting a Greener Future, which is into its 12th successful edition this year. This is an extended platform of Foundry Review which draws together Foundry experts and industry fraternity to exchange ideas, information and issues concerning the industry. Each year, through some enlightening presentations and panel discussions that are put together by experts, we have been delivering content and panel discussions on pressing issues related to the industry. Today, our team is back once again with a mix of session providing resourceful content on issues like castings overview, evaluating Foundry's growth, commercial perspective, technological transitions, and new products. We are glad to see a gathering of an enthusiastic and eager audience today. Our participants include professionals from foundries, casting manufacturers, equipment suppliers, coating binders, industry researchers, government bodies, academia, and so on. Friends, as we start today's proceedings, may I request everyone to switch off your phones on silent mode. Thank you. May I now request Madam Beena Verma to lead the seminar proceedings with the welcome address.
Good morning, all of you. Good morning. Welcome to the 12th annual gathering of Casting a Greener Future 2016. It is great to see a class of over 125 fellow friends from foundry and allied industry today here. We at MMR Events are pleased to host this consecutive 12th seminar and making it a landmark event devoted to the foundry and casting industry in Pune. And this has been possible only with you all by our side. It makes my job very easy to introduce the leading dignitaries and the honored distinguished guests and the leading distinguished guest of the day, captioning as the team comes back. A very warm welcome to our leading distinguished guest of the day, evergreen personality of the global foundry industry, who needs no introduction, Mr. Vinod Kapoor. What makes him special? His passion for the foundry reflects in every walk of life, his lifestyle as well. Foundry Review has taken a lead in capturing the foundry artifacts from his office and as well as his residence. Read it in our latest issue of Foundry Review. I'm sure nobody would have been able to capture this. Worldwide, they will get a view of his collections lifelong. We are privileged to have all his support and guidance in shaping our publication and these seminars as well. Thank you, Mr. Kapoor. We will have the privilege of hearing him on the overview of global foundry scenario immediately after I welcome you all. Thank you, Kapoor Saab, for your presence as always. We are privileged to have with us this morning Mr. Paneer Selvam Ramaswamy, Principal Director, MSME Technology Development Center, for the first time, and I'm sure will continue in the years ahead. And we have never seen him in any of our foundry forums, so I'm sure you will all be very keen to hear him out today. A very warm welcome to you, sir. We extend a very warm welcome to our honored panelists of the day who have spared their valuable time to be with us. Mr. Narsimhan, Executive Director, Brakes India Limited. Thank you so much for coming. I think we've been waiting for last 4 years consecutively that he'll be with us, and this year has made it. Thank you very much. Mr. Subodh Panchal, Managing Director, Castival Foundries. He's been a well-wisher and supporter of our group. I think the very first seminar which we had at Ahmedabad, he was our first chief guest to roll it on. Thank you, Mr. Panchal. Mr. Gyanamurthy, who is not here with us, genius foundryman, I would say, who would be joining us shortly and who would be talking with his experiences and much more. So let's give time when he takes up the moderation in the afternoon session. Mr. Sundaramurthy, President, Fenfe Metallurgical, again a well-wisher of our Foundry Review and who has been helping us out in the technical issues and also moderating our sessions in the past. Mr. R.V. Belve, Executive Director, SECO. Mr. Anirudh Kamdar, MD Kunkel Weiner India, again a very good supporter for our industry and the magazine especially. Mr. Mukhopadhyay, who will be joining us soon from Elkem India. And representing Mr. Firodia, Mr. Vivek Joshi from Jai Hind Industries. And our moderator for the day for the panelists, Dr. B. Basudkar, Foundry Advisor. Thank you, Mr. Basudkar. I'm sure he's here. Yeah. Thank you all being with us this morning. We look forward to a very interactive and informative sessions and on evaluating the foundry industry shouldered by Dr. Basudkar. A very warm welcome to our esteemed authors of the day. We keenly look forward to your presentations. During the course of the day, we will be discussing various issues revolving around the industry to work together and with great diligence to identify impediments against its growth and sustainability of the industry and to discuss the strategies to combat them. The outcome of today's deliberations would enable us to move in that direction. And the most important, we would like to thank our financial supporters who are doing a service to the industry by supporting our seminars. Thank you very much, and I think many of others should be joining to service the industry. I won't say sponsor the events or support the publications, but to service the industry, we all have to come forward. Gargi Hutchins Albertus, Magma Engineering Asia Pacific, Amcol, an MTI company, Dorentrup, Inductor Therm, Morgan Crucible, DISA, Kunkel Wagner, and Alicon. I'm very happy that at the very last minute, Alicon has come forward and they have sponsored it right today in the morning. People do only delegations in the morning, but we have a sponsor early morning. Once again, I would like to thank you all for coming. Your expertise and spirit to share and impart knowledge is highly appreciated and is the need of the hour. We look forward to a stimulating sessions and discussions. And last but not the least, I would like to give a special acknowledgement to the team at MMR who have worked day and night to bring to this a wonderful platform for exchange of views and news. And over to my colleague Paresh for taking it further through the day's proceedings. Thank you very much. Have a pleasant day.
Thank you, ma'am. May I request Mr. Vinod Kapoor, who needs no introduction, to lead the sessions with his presentation on global overview of castings market.
Good morning. You know, she just mentioned, this is a 12th program today, and it's nice to be here. At least I've been present for last 9 programs. Subodh beats me to it. No, the 12th one. Mrs. Beena Verma, my friend Mr. Narasimhaji, Subodh, Dr. Sundarmurthy, Dr. Basutkar is sitting quietly on that side, and Mr. Kamdar and my other friends, Arjun Vadkar, and dear foundrymen, ladies and gentlemen. Today, once again, we have a very interesting program, and I'm privileged to be here today. It's not only the 9 years which I've been with it, and this is the 12th program. And last 5 years back, we also had published a Foundry Review magazine. And 9 years back when I came first time, I was wondering whether Beena ji will be able to sustain this program in the foundry industry year after year and continue. You know, foundry is a men's world, and when any lady comes in for any of the programs, she's looked, you know, okay, theek hai. But I must compliment her. She and her team have done excellent. 12 years, they have sustained it, and they are being recognized by the foundrymen all over, not only in India, but internationally also. Congratulations. I just finished my 2 years term as a WFO president. Sometimes a lot of people ask me also, what was it? What do the countries who are the member of WFO gain from WFO? That's a World Foundry Organization. WFO is an excellent reference point for the global metal casting industry and international network of contacts that provides a direct access to the latest technology and statistical information from the most representatives of the countries. WFO enables us to share very interesting information and facilitates the forecasting of some of the new challenges and opportunities for the global casting industry in the near future. Just last month, WFO, we collected from each member country the foundry status in their own country. And this is a fantastic information which you can have if you want to know all out of any of the 30 countries what is the foundry status. Otherwise, it would be impossible to put 30 countries together and collect the data. During the year 2015, we went a step ahead. That is, WFO is managed by an organization, or I would say an office, which is located in Birmingham. We found that it required a backup, a very strong backup. Therefore, we signed an agreement with the Azterlan and the Tabira Foundry Institute. They are based in Bilbao. It's one of the most well-known foundry-rated institute and laboratories and research work in Europe for auto sector. people who are doing work in this line, they'll understand the strength of Tabira Foundry Institute. And we signed this agreement to work together in providing high-value information about the global casting industry, including key areas of change within each country, that is, output trends, market trends, and current issues, whether these are environmental, energy, or customer-focused. Providing update information from most of the main players in the global casting scenario. During May this year, I was in Japan to attend 72nd World Foundry Congress and the exhibition held in Nagoya City. Last 2-3 years, I can see a common requirements and developments among the top 10 casting producers around the world. And they also have a common problems. The foremost problem was attracting the next generation. Now this has become the main problem every country which produces castings. Finding future members of the metal casting industry involved reaching out to students at all levels. This is one area where in India I find many foundries trying their best to get good and intelligent candidates from ITI, NIFT, and other institutes. In each country, institutes play a very important role in sharing the knowledge and attracting students to the metal casting industry. But in our country, we are still far behind. We have a long way to go. In the next steps in the metal casting development through emerging technologies and ideas, I would like to share a few of them. Economic and timing benefits of 3D printed molds for prototype and production castings. This has really created a revolution in the industry. Of course, many of you have read about it. Many of you must have seen about also. There's a company in Pune also now based on this, and it's a subject by itself. Then predicting casting dimensions with the computer process modeling. And of course, Industry 4.0. What it means to the foundry industry. As you know, 4.0 stands for the fourth industrial revolution, which at first sounds extreme. But when you start to look at the possibilities, it's easy to see how these technologies can become real game changers. Industry 4.0 is a brainchild of German government, and the train of thoughts is to create smarter, more efficient manufacturing through the use of smart factories in the not too distant future. This is one topic which is being discussed at many places, and also how it can be applied to foundry industry. Last 2 years, many of the foundry seminars or the congresses, I could find this one of the paper as a very common paper. About the raw materials used in the foundries, the demand is shifting towards high performance applications. Another move has been cast iron castings are being replaced by aluminum castings, especially in auto sector, in particular in Germany. In the Fortune Global 500 companies list, over 150 companies are from Asia, a shift that is only going to accelerate. We have seen the phenomenal success of Indian IT companies globally, the incredible turnaround of the ailing Jaguar by Tata Motors, and more recently, the success of Royal Enfield from India taking the leadership in the international markets. So let us think what we can do to attract foundries to our country with the government support under Make in India to manufacture their requirements in our country. a major happening in the global scenario is a shift of sourcing and manufacturing basis for castings from developed countries, that is Europe and US, to third world countries, especially in Asia. Now, my statement is based on the statistics provided by AFS. This is the right time to bring them to India, especially when our GDP is around 8%, our economy is growing 7.3% plus. So I feel this is the right time we bring them in, and some of the foundries are coming in. Worldwide casting production is growing. In last year, it had grown by 2.3% increase in comparison to earlier year. When you see these figures, you'll understand, out of 105.17 million ton, nearly 70% castings production are from Asian countries. And of course, China has a major share of more than 44%. But it is a good sign for India. Recently, in last 3-4 months, we had a downtrend. Things had become too quiet. Everybody was very cautious about putting any money into the foundry, or for that matter, any expansion. But I can see in last 3 to 4 months, I am attached to a company which is a supplier to the foundry industry. So as a supplier, we know the nerve of the industry. We found that last 3-4 months, we started receiving a lot of inquiries for the capital equipment, like for example, mixers and reclamation plants and so on. And also, last few months, many of the foundries, their offtake has been very consistent. Otherwise, it used to be seesaw, 1 month, good schedules, next month, bad schedules. But looking at what is happening, or this is a reality, I feel we are in right track. The foundry industries are moving ahead. So these were the few things what I thought I could share with you. And thank you for your patient hearing. And thank you, Binaji, for inviting me. Thank you very much.
Thank you, Kapoor sir, for that speech on the overview of global castings market and also elaborating on the activities of WFO. And may I request you to be seated there as we begin our next session on the evaluating the growth of foundry industry. May I request Dr. P. Basudkar, Mr. V. Narasimhan, Executive Director, Brakes India Limited, Mr. Subodh Panchal, MD, Castwell Foundries, Dr. Sundaramurthy, Managing Director, Fenfi Metallurgical, Mr. R.V. Bele, Executive Director, SECO, Mr. Anirudh Kamdar, Managing Director, Kunkel Wagner, Mr. Gautam Mukhopadhyay, Vice President, Elkem India, to take the dais, please.
Hope for the foundry industry developers. The panelists today, we have Mr. Narasimhan, Executive Director, Foundry Division of Brakes India. He initiated green manufacturing in the foundry division, which is now rated as a green company with gold rating by CII Goldridge Green Business India. But very few of you may be aware that Brakes India is the only foundry in the world who's got the quality award. Mr. Narasimhan, have you My friend Subodh Panchal, Managing Partner of Castwell Industries, is a past national president of the Institute of Indian Foundrymen, with which he has been associated with for over 30 years, and I think he will continue to do so till his last moment. Mr. Sundaramurthy is president of the industry body, the Indian Foundry Organization. He is also the past chairman, Environmental and Energy Saving Commission of World Foundry Organization, and past national president of the Institute of Indian Foundrymen. Mr. Anirudh Kamdar, an engineer by profession, is a founder and managing director of Kunkel Wagner India Private Limited. He has several years of experience in marketing furnaces, fluxes, and foundry projects and foundry equipment. I think I'm expecting him to contribute towards enlightening you about the new developments in the foundry and the molding and the sand preparation processes. Mr. Gautam Mukhopadhyay, he would probably be joining us a little late. He is a Vice President Marketing at Elkem South Asia Private Limited. He has a solid 30-year exposure to steel, foundry and aluminum industries and his challenges in India and abroad. He would be coming, I believe, a little late. Mr. Ramchandra Bele, he's not come, not yet. Ramchandra Bele is the Executive Director of Srinivas Engineering Auto Components Foundry in Talegaon. He has been associated with companies such as Bhilai Steel Plant, Gadge Patil, Kirloskar Fetters, which were earlier known as, what was the name in Sholapur? Shivaji Works, and Suzlon Energy, etc. Mr. Vivek Joshi. Mr. Joshi is a Senior General Manager, Quality and Systems at Jai Hind Industries, is aluminum foundry, Ferodia Group. He is responsible for new product development through APQP process. He was trained in Switzerland in the die casting process engineering at Buehler. And some of the points of discussion I will just note down. Points are given, but I would indicate some of the aspects which I would request the panelists to cover. I'm looking at this panel discussion to make you aware of the developments in both equipment, materials, and keeping in mind what the government's of directive is to the industry, that we have to meet by 2020 Euro 6 norms for pollution control. And I think it needs to be told, accepted by the foundry, that we are already very late in accepting some of the new materials which are required to meet these requirements. So what are we looking at? We're looking at emerging foundry equipment processes and process controls. It's amazing that we are in the industry for more than maybe 100 years, but still we have the casting quality issues in most of the industries. Wherever you go, you talk about people doing trials to establish the quality. The little respect is there for the process control. I think we need to pay more attention to process controls in the foundry. We should be looking at opportunities for a government's initiative. What do we need to do for the foundries? The panelists should look upon how to increase the foundry capacity. A lot of foundries have been adding capacity, and there's hardly 60% utilization. What can we do to make the utilization of the available capacities in the foundry? Accepting competition and pricing and quality of the castings from China. Issues relating to greener environmental. How to control the waste and recover material from the waste material. Coarse sand processes have already been started. What do we do about the molding sand wastage? Can we recover the molding sand? We should look about the quality issues emerging when process control and documentation is not practiced by the foundries. Foundry raw material suppliers, I expect the panelists to indicate, no longer it is the supplier's prerogative to just mine the sand and supply to the foundry. They have to look about the quality requirements of the sand before they supply the quality cast materials. 3D prototyping, we just spoke about it for new product development. Automation to improve the quality control, quality of output of castings. Simulation software are available for solidification, for flow of sand, for flow of metal, for core filling. Simulations are available for residual stress analysis, for material quality. And finally, the panelists should discuss how to benchmark the pricing of the casting in India. And because we are all trying to get the orders at the cost of killing the other foundrymen. With this few words, I request to the panelists to start the discussion. Shall we start with Mr. Narasimhan? You are experienced, you got environmental contribution. Now give us the challenges.
Thank you, MMR Jinaji, for having given me the opportunity. I'm being fifth time lucky. I'm very privileged to be here. I'm also very glad to see the rest of the panelists and of course our own Vinodji, meeting him after a long time. Now, the seminar is about casting the greener future and also what is the opportunities for growth and how to evaluate growth. Now, I'll take this a level beyond green foundries. There is unprecedented turbulence and volatility in the market, which is here to stay. It cannot be wished away. Now, we need to look at our own sustainability index. sustainability is just not about environment. It starts with economics, it goes down to social, and also includes environmental aspects. And of course, there is socio-economic, economic, and social and environmental and economic. There are lots of factors which overlap. Now, what do we mean when we say economic sustainability? The foundries should be able to stand on their own, should be able to make profits. Profit is not a four-letter word. Profit is required to pay your employees on time, to get the right type of equipment, pay your vendors on time, and also contribute to the society. So we can't be, wishy-washy about profits. Profits are important. Profit alone cannot be the ultimate objective of the industry, but the return on investment, payback, the level of automation, the productivity, all these things come into the economic factors. Then when you come to social, Vinodji touched about the subject. How are we going to attract young engineers? How are you going to attract the young generation to come and work for you? You know, what is forgotten from being a dirty, difficult, dangerous industry in all these years after the recession, after 2008, 2009, what should I say? Massive improvement in quality and massive improvement in productivity have got hidden by, and the reduction in costs have been hidden totally. It's been forgotten. So how are we going to attract young talent? How are we going to improve the human resource management? These are all the things that come under the social aspects of the sustainability. Social aspects will also include the contribution of the industry to the society, and especially most of us will have to go, of a particular size, have to go to the so-called backward areas. We have to we can't look at our jobs as just 7:30 to 3 or 8 o'clock to 4 o'clock. It's a 24/7 job. And we have to identify ourselves with a village or town or whatever and see what we can do for the upliftment of the village economically. Our CSR is definitely a social aspect. So how do we progress on the social front? Then naturally the environmental aspects come. Environmental means just not energy. I welcome Gautam.
Thank you very much.
Nice to meet you. Mr. Gautam Mukhopadhyay was a little late coming, but I introduced you.
Good morning, all of you. I'm sorry for the interruption.
So the green manufacturing is all about, energy management, how we are using other unconventional sources which are renewable, and how much do they form a percentage of our energy consumption. We are energy guzzlers. So how do we manage energy? How do we manage the waste? How much are we, the recyclability is the biggest advantage of the foundry industry. So how are we converting the waste, which is 4% of the top line, and take it to the bottom line? Waste management is important. Last century was fought on oil. This century is going to be fought on water. So how are we going to manage the water? Water management and being water positive is very, very important. How are we going to reduce the emission of greenhouse gases is important. We have to also look at the product life cycle management. I said the recyclability is a big advantage of the foundry industry. Now, we cannot talk of cradle to grave. How we are going to go from cradle to cradle. The casting can be, reworked and a lot of replacement can take place after refurbishment. So the cradle to cradle concept has to come, and it has to start with the engineering. One of the changes that we need to make also, we need to get involved with the design of the castings. No more a time will come when the drawings and the specs will be given and will be judged by just how our capacity to meet the drawing specification and the tolerances. Much more, how are we going to take care of the unstated needs of the customer is going to be the key. Then product stewardship. What are we, how are we going to enhance the attributes of the products that we make to make it more attractive, make it more environmentally sustainable? All that we need to look at. So green manufacturing, I will very strongly recommend as a route to this, and we have to keep in pace. Having said all that, I totally agree with Vinodji when he said that we can't take our foot off the accelerator. There are still opportunities to grow, and we should not miss those opportunities. Second, let us not go on looking at our competition. Let us look at the customer. Let us try to satisfy the customer at least 3 minutes ahead of the competition. And most important, risk management is not a checkbox. Risk management should become one of the key strategies of the management in the future. We can't lose track of this. And let's not take it for granted. We are at the crossroads. I definitely find that every job will not shift to India. What has happened in the US in the last 9 years, 10 years is enormous. There has been no increase in wages from 2007 to 2016. Number of people who work in the foundries have come down. Enormous amount of automation has taken place, and what should I say? The robos or whatever automation is become less expensive. You don't spend a whole fortune on automation. We have to look at that, and because of all this, productivity is fantastic. So our cheap labor is not going to matter at all. Whatever was your competitive advantage earlier is not going to be the competitive advantage in future. We have to look at how we are going to adapt ourselves to the changes. Changes are going to be permanent, and how we are going to adapt ourselves to the changes is the key. These are my initial thoughts.
There are thank you, Mr. Narasimhan. There are two or three points which come up over here. One is the productivity. The highest productivity in the world in the foundry industry is in between Germany and France. Approximately 95 tons per man per month. 95 tons of man per month. That's the productivity level. And in some of the best foundries in India, we have been able to achieve a value of close to 20 tons of man per month. So there's a gap that's very huge. A gap needs to be filled up, number one. Number two, for your benefit, Breaks India Foundry is one of the very few foundries which have been able to use the waste generation, especially the foundry sand, for making bricks and tiles for the roads. When time permits, you can check with Mr. Narasimhan in the break time to see how they have been able to achieve this thing. Now, I request Vinod, just to interject so that we can open the thing as far as the new developers are concerned. Mr. Mukhopadhyay and Mr. Bele just joined us, and I'm expecting some kind of a contribution from you gentlemen for the new materials which are coming up, and we have to meet the requirements of the government's directive for 2020 Euro 6 norms. What is your take on that thing? And then we will, after Vinod Kapoor, we'll go to Mr. Subodh Panchal, and then he'll take his questions. Thank you. Vinod.
Thank you, Doctor. As a supply to the industry at our end resins we have been doing a lot of developments to suit to Indian conditions. When we take the original recipes of what is happening in Germany, when I say Germany, because Germans are our partners, it's two different platforms. At our end, we are looking for raw materials, or we have developed product with their local raw materials, where the addition levels are low, emission levels are low, and price is the main criteria again. Today, especially in the last 3 years, every foundry didn't want to try any new material. They were looking only for the lowest and cheapest material available. But now, I think with the trend might change with the foundries picking up, they're getting a better price from the customers, or they feel by use of these materials, they'll be able to gain. So that's in sign of resins. As far as coatings are concerned, we are doing a lot of developments, a lot of raw materials. Again, most of raw materials are based on Indian raw materials, local available. Whenever we think of any imported raw materials, the cost goes up very high. So these are the two areas where we are doing developments, and I'm sure another area has been there, a tailor-made resins at low price. As you know, the sand has become the main problem in every foundry. The availability of sand is there. We develop a product, we give it to foundry, but suddenly after 2 or 3 months, at their end, the sand source changes. The moment change takes place, it gives a different results. Now that's one area where we work together with the customers, and okay, one more area where I find what is missing, a good foundry men. Finding a people to work in the foundry has become difficult, as I said earlier, and maybe more and more training to the youngsters who are coming through ITI and NIFT and other bodies will definitely help the industry. Because now I find not only there, in some of the well-known foundries, in the laboratories, they have taken contract people to do the job. Now what can you expect? I don't know. If a little change is there, the fellow is going to do his contract, he's supposed to do so many samples per day, he does it and it's over. So that's another area where foundries have to look into it. And as Mr. Narasimha is there, he's the actual foundryman. I've been his great fan for more than 20 years or 25 years. He's a fantastic speaker. Today we heard him only just a few seconds, a few minutes. So maybe he could also tell us later on size of his foundries. How do they create a good foundryman from the ITI or NIFT or whatever other source they have? Thank you.
And thank you, Vinod. I think one of the points which Vinod raised, I think, is needs to be discussed amongst us, is the quality of sand. We have been only used to ordering the sand and getting the sand. Just for information, people using the cold box process, for example, in Europe, they use 0.6% resin, part A, and 0.55% part B resin to produce very, very good coat quality. In India, with the quality of sand available to us, the minimum we need to use is the minimum 0.9, 0.86 is what has been benchmarked and used by a very well-known foundry group in Solapur and Hospet. But generally, people are using 1.1, 1.2, even 1.3%. So you see the potential in saving the resin if you get proper sand quality. So what is the important part is the shape of the sand grains and the elimination of fines from the sand grain distribution to be able to use lower levels of resin node. So I find it very difficult to tell him Mr. Panchal. I've been always been calling him Subal. Okay, Subal, please take over. I would expect you to touch upon some of the points about the new developments and how we can help the foundries identify what the new developments are and how, as foundrymen, we can help them to get those things. Subal.
Thank you, Doctor. I would like to start with some lighter side. Senior foundryman, after a marriage of 30 years, once late evening he got a call from his wife. He was sitting in the office. He said, "Why you are so late?" He said, "No, we are discussing on pinhole problems." Wife said, 30 years back when we got married, that time also you were saying the same pinhole problem. Even now you people have not solved that problem. So this is the life of the foundryman. New development, yes, recently in my visit to Mattel, China, 2 months, 3 months back, I observed that ceramic sand is coming in a big way. There are many new manufacturers have come up, and ceramic sand, of course it is beyond the reach of the average foundryman now, but if you consider that 9% of recycling possibility technically, and as doctor said, resins consumption is just 50%, less than 0.4% addition. Vinodji will not be happy, of course, but then these are the things coming on horizon. And ceramic sand, it is artificial sand, synthetic sand. So no more dependability on our mining regulations and other things. So these are the things. Another thing is coming is of composites. Now composites, I met one Dr. Rohatgi who is working in Milwaukee, USA for years. He had visited India last year after a gap of this thing. He said they have a technology to introduce this carbon composites, silicon carbide composites, and others for the cylinder liners manufacturers. And the saving on a fuel, it's a lubricant itself is in millions of dollars worked out in the USA. So there are some parties taking this kind of technology. It is also available. Our own Indians are working there. And these kind of things are available. During my China visit, I also come across some professors, and when on return, one Dr. Gautam Sutradhar from our Kolkata, he was interested to join somewhere in China to study further on the composites, and then I was instrumental to organize his stay there. And there is Asterland, as Mr. Vinodji said, #1, and another this institute, they are the #1. But sometimes European standards are beyond our reach, there we cannot afford. Whereas silently these Chinese institutes are also doing a great work, and they are in a day-to-day contact with the industries. That is their main advantage, which I have observed during my visits to China in the last 20 years. Now, many of you, since we are whenever question comes of competition, first name comes to China. Now, what scenario in China? I will just give you some figures for your information. These are very fresh, just 2 days back I have received. Price of steel melting scrap in Indian rupees works out from 18 rupees to 20 rupees per kilo, which is almost same in India. Pig iron price is also 16,000 to 18,000 depending upon the grade per metric ton. River sand 600 to 800 rupees per metric ton. Silica sand is at 1200 rupees per metric ton. Now, very, very important thing. We were saying so far that China is a very cheap labor and other things. It's not so any longer. They are paying ordinary foundry worker up to the tune of 12 to 2,500 rupees per day, minimum wages I'm talking about. Imagine 1,200 rupees is the lowest one, minimum wages in some remote area. It goes up to 2,000 rupees per day also wages. So average foundry worker gets about 40 to 50,000 rupees a month there. And electricity, that is about 6.5 rupees per kilowatt per hour, which is in India we are about 8 rupees, 7 to 8 rupees in different. But there in the night charges are 4 rupees per kilowatt. Per hour. That is there are some advantages there. But on the other side, many small and medium foundries have closed down there because of the pollution reasons, increase in international transport cost, and manpower. And plus, many of the raw materials like ferroalloys and other, it is a reverse. Normally, export is motivated. In China, there is a 15 to 20% export duty. If you export the ferroalloys, you have to pay to the government, so your products become higher. So mostly the ferroalloys manufacturers were sending their products via Vietnam border illegally, which just 15 days back, Chinese custom had a huge raid and confiscated about millions of dollars of worth. So that route is also closed. So that is one of the reasons of recent increase in raw material prices from China. And due to this, some of the reasons, now I personally believe that there is a scope for Indian foundry men also. We have heard 5 years back that our organized buyers were saying, okay, if you don't supply, we'll buy from China. But now in China also it is no longer cheaper. If we are giving, as Mr. Narasimhan said, if we focus on quality, then we Indian foundry men has a good chance. Recently, just 3-4 days back, you might have seen this trade advisory has been issued by the Consulate General of the Shanghai, which is mentioned do's and don'ts about the increasing frauds with the Chinese company. I have circulated by mass mail to many of our customers. And in that response, it has reached to one of the German buyer. He replied that this is a good information, but let me tell you that we depend fully on Indian suppliers only, and mostly from Bangalore side and other things. So we should understand our plus point, our strength also. When we are talking about weakness, we should be aware of our strength also. So these are for the Chinese, and later on during the session, I will share further information.
Thank you so much, Bhai. Let's get also moving into some of the newer materials. You probably have heard about CGI, the compacted graphite iron, which is a replacement for the high-density combustion engines where the pollution norms have to be met. Already for your information, companies like MAN truck engines are already being made in CGI iron. And this is going to be the need of the day as far as the meeting the norms of YODO are concerned for pollution control. The next development, which is rapidly picking up in the last maybe 2 years, is the ADI, the Austempered ductile iron. There's also been Austempered grey cast iron, which is being used for certain liners for use in CNG engines. And these are some of the developments. And earlier, there would be specific heat treaters who would be doing the job of heat treatment of this casting, Austempering of this casting. And now more and more companies are installing their own in-house heat treatment facilities. So these are some of the things which need to be done, and depending upon the volumes which are required to be produced, up to 100 tons per month, up to 200 tons per month, there are other alternative materials, methods available for making CGI. But when you go to 1,000 tons a month and plus, 2,000, 3,000, 4,000 tons a month, for example, blocks and head castings for trucks, used trucks, you need to go for a very proven technology like a Sintercast process for making CGI, and anywhere from maximum would be about 3-ton treatment per batch, and nothing more than that thing. But minimum would be about 850 kilo treatment to 3,000 ton. I think we need to be aware of these developments so that we are prepared. Even if you don't get the orders for making CGI and block and heads, I wish everybody, I would recommend that at least you make the process, you document the process, and if you get the orders, go ahead and start producing it. But don't wait till you get the orders. Have your process ready beforehand, and this is my recommendation. Anirudh, people have been talking about the processes, the environment. I would request you to just touch upon what are the new developments in the equipment which is being used in the foundry, especially for molding. A lot of people are going in for so-called high-pressure molding. Now, high-pressure molding is not something which you press the button and they get quality casting out of the machine. It doesn't happen that way. The most important thing is the discipline, is the process control. And the very fact that we are having so many foundries, having so many problems, and our average world-class level of rejections in a foundry is considered to be world-class if you have for casting like block and head less than 3% rejection. In the foundry plus machine shop, that is considered world-class. Less than 1% rejection for tractor type castings, foundry and this, that is considered world-class. Less than 0.5% rejections in HGN castings, that is considered world-class. Now you compare where our foundries are and see how far we are from the world-class requirements of the quality. And one of the biggest problems, I believe, in my opinion, and I visit quite a few foundries, is our lack of respect for process control, our lack of respect for documentation, and a lack of respect for following the steps which you have written down in documentation. Please revisit the documentation that you may have prepared for your foundry processes. Raw material inspection, preparing a sand for molding, for cold making, for metal preparation, for inoculation, for treatment, for pouring, for gating system design, for fettling, for heat treatment, whatever. And not one process is important. All the processes are important. They should give the same quality at the same time to get the same quality output. Please keep that in mind. Anirudh, please take over.
Thank you, Doctor. Before I talk about molding processes, I think I would like to take off from where Vinod uncle stopped on sand. See, the most fundamental raw material for making a mold is the sand. If you don't have the right quality of sand, if you don't have the right properties of sand, and if you don't have the right sand control, there is no way that you can produce a good mold. So, and this, I think, is something, this understanding is still lacking amongst all our foundrymen. Yes, big foundries, leading foundries, etc. are certainly adapting themselves to ensure that they are able to produce a good quality of sand. A simple thing like sand temperature for molding is still overlooked in many foundries. The right temperature of sand for a good mold is known to all of us. We all know how the curve goes of moldability, and beyond a certain temperature how it suddenly falls. The requirement of a simple thing like a sand cooler, whoever may be the manufacturer, hence becomes a fundamental requirement. Having said this, yes, I do agree and accept that we cannot change the laws of physics, and the amount of cooling that can be achieved is always limited by basic fundamentals. But these three things put together, the quality of sand, the temperature and mixing of the sand, and in today's terms, online control of sand is extremely important. Having said that, let me go to the next thing about what Dr. Basutkar actually asked me, is molds. I am presuming that a very large part of the audience here is related to automobile and automotive castings and industry. Friends, we are all today talking of Bharat 4, Euro 6, etc., etc. I have been interacting with some very leading foundrymen in our country itself. And when I look at and try to understand what the requirements of these norms is, let me assure you they're not simple. Uniformly high mold hardness across the mold is something that is going to be absolutely critical and essential. The tolerances that are now going to be required are going to be very, very high. Stringency is going to be the norm, and this is not going to be restricted to our country because, as mentioned earlier, there is an inflow of orders from the developing countries to countries like ours. Let's not talk only of China and India. There are several other developing countries, Turkey, Korea, Vietnam, all of whom are competing and vying for these orders from the developed world. So, if we want to really meet the global requirements, there is a lot more to be done. Earlier we used to talk of squeezing molds from the top, jolt squeeze machines, simultaneous jolt squeeze machines were the state of the art. I represent a German molding machine manufacturer, as most of you would know. We also were very satisfied with the type of squeezing process that we had. And we've realized in the last 3 years that what we used to give is no longer valid. We need to have a mold which is uniformly hard from the top and the bottom throughout the height of the mold. And that is the new technology that has been developed, not just by us, it's also by other molding machine manufacturers. Having said this, let's not underestimate that the accuracy of a casting as now required and demanded will not be achieved by a mold alone. Core making and a very high quality and high accuracy of core making is going to be essential. I know certain core making manufacturers, core machine manufacturers, like Loramendi in Spain, who are also providing a hand-holding facility today to foundries so that they are able to develop cores of the type and nature that will be required by industry. I would say these are the three fundamentals that I would like to touch upon at this stage in reply to the question that you made. There are other points maybe we can take up later. Thank you, Doctor.
Thanks, Aniruddha. Let us talk about two or three very basic things about the process controls. The one thing which you spoke about is the sand. Now, when we prepare the sand, most of the time, whenever there's a problem with the molds, the first man that goes and gives the instruction to the sand preparing operator, "Arey, sand mein pani bada de yaar." Pani badane se you will get good molds, but there is no guarantee you will get good castings from those molds. I would rather have 2 or 3% mold breakage, but the remaining molds will give me 96-97% good castings. One of the a secret, like you may say, the secrets of preparing good sand for molding, the secrets, have the sand which needs minimum compression strength for making the molds. And then add the bentonite or binder, minimum amount of binder to achieve that compression strength. Then add minimum water in the sand to get that particular active bentonite. And with the minimum water, get the minimum possible compactability which will give you the molds consistently. The summary, minimum strength required, and the strength required is a little bit more for flaskless molds as compared to those with the flask support. Minimum actively, minimum water, minimum compactability. The lower the water, the lower the compactability, the higher is the flowability of the sand, better compaction of the sand around the pattern. And gentlemen, the surface of the casting is a mirror image of the surface of the mold. And the denser the mold and more compacted the mold is, high density compaction will give you a good surface finish. Apart from whatever may be the raw sand, AFS number, etc. And the second thing is, the development would be proper pouring of the molds. We take care to make good molds, good cores, good assemblies, good metal, good inoculation, good treatment, good thing. And the lousy last step is lousy pouring of the castings. And all the effort which I've made to making a good mold and everything is lost by a lousy pouring. What's a good pouring practice? A good pouring practice involves taking the ladle spout as close as possible to the mold surface, targeting the spout of the ladle in such a way that when the stream of the metal comes out, it falls in the dead center of the pouring cup or the pouring downsprue. Initial pouring should be so fast that you pour the metal and see the metal in the pouring cup in the first 10% of the pouring time for that particular mold. If the pouring time is 20 seconds, in 2 seconds you must be able to see the metal in the pouring cup. Unless you achieve this condition, don't even look at the quality of the casting. Forget it, that's secondary. Because the defects which occur in the casting is, if these conditions are not met, you will have problems in the casting. And then the pourer should just maintain that level. If the metal level goes up, he reduces the level so that the metal does not go over the molds and choke up the vents, etc. And if the metal level goes down, he increases the level, because at any given time from the beginning of the pouring till the end of pouring, you must see the metal in the pouring cup. If the metal is not in the pouring cup, slag, sand, gas, or whatever you have will go into the casting cavity. Please keep that in mind. And this function is achieved by an automatic pouring device like a press pour or whatever you want to call it. But when you have a press pour, use it as an automatic pouring device. Don't put a man there with a joystick papering. In that case, all your molds are poured variably. But if you have an automatic system, only first 1 mole, 2 mole, 3 mole, okay, you want to set the process. But after that, let the man just stand like this. So this is as far as the good pouring practice and the sand preparation are concerned.
I want to interject.
Yeah.
I can't disagree with you on the good quality of sand leading to reduced use of resin, everything else. There is another aspect. Productivity is also affected because, when you produce 350, 400 moles per hour, we are never able to go beyond 2.5 kilograms, 2.8 kilograms per second pouring rate. You're talking of automatic pouring and all that. With good sand, you can go up to 5 kilograms per second. It's a pipe dream. Okay. Now, that's where innovation comes in. Now, the Western world went for 3D printing, all that. We are good at innovation too. And what we need is a kind of jugaad innovation, which is very, very cheap. Now, I can't achieve more than 2.5 kilograms per second, but I need to show my customer that my productivity is 500 moles an hour. They want a clean sheet. I have to stand naked, expose everything, all the parameters in my cost model. So I have to show 500 kilograms per second. So why not 2 pouring nozzles? Why not 2 pouring machines to see that we still achieve 5 kilograms, not 5 kilograms per second, not 5 kilograms per second, but 2 into 2.5 kilograms per second. So innovation is very important. Then I'll go back to one more. We are partially suffering because only the Indian foundry industry is catering to 30% of automotive requirements. Lot of innovations, lot of improvements come with the automotive industry. Rest of the world supplies 65% of their production to the automotive industry. We are lagging behind because we are only 32%. Such a disciplined industry. I know it's very difficult to survive with survival of the fittest, but we are going to start improving only when we compete with the West. I would definitely recommend for further growth, we should go more and more into auto industry.
Let's talk about the manufacturing of castings. We have got eminent casting producers. For ferrous, we have got Mr. Ramchandra Bele, and for non-ferrous, we have got Mr. Joshi, Vivek Joshi. Let's get their views on how is the foundry industry getting ready for newer materials. I do not know if people are going from aluminum to magnesium, but Mr. Bele can certainly talk about going from cast iron to whatever else he is going to. Bele?
Basically, I want to talk about, something about the cost of the quality, The cost of the quality, we spoke about so many parameters which are to be controlled. And how we are going to control the sand, and how we are going to use innovative materials, and how we are going to use various equipment. But we are quite negligent about cost of poor quality or the effectiveness of the equipment what we use. Actually, now every foundry has understood to use, or they have understood that they need a high pressure molding line, they need an automation in core shop. But if you look at this overall equipment effectiveness of all our foundries, is maybe barring some of the companies like Brex India, all other companies have a very poor overall effectiveness, overall equipment effectiveness. And that is because, we talk about processes, we talk about process adherence, process control, but very less concentration is given on the people, training of the people. According to me, there is a need of, rather, you see, whatever we are sitting over here, our age group itself, if our average age is worked out, it may be, I don't know, it requires calculation. But, very, very few young people are, he may be. That is why I said it requires workout. There is a requirement of looking at people, there is a requirement of, lot of training and understanding of Rather, various quality tools are to be required to be used. Very few foundries use quality tools. Now we spoke about sand control, we spoke about this flowability of a sand and all. All these can be controlled through the proper training of the people, proper processes of use of quality tools. Very less quality tools are used at the pouring station, at the melting station, at the sand plant or at the core making. The foundry culture, rather what we are after, I want to claim that as everybody takes the name of the Brix India for a foundry processes or a foundry control, we want to create our own foundry manufacturing process. We want to create our own quality system. We want to create our own culture of controlling a foundry. Last year we sold about 37,000 tons of casting. This year we have a target of selling more than 54,000 tons. I hope that the good rains may make it happen. But the requirement is, there are various requirements from OEMs also. Today all the OEMs, are having 4, 5, 6, 3, many different sources, And the requirement is the appreciation of the cost which is required for a producing quality, which is required for an automation. The foundries, those who have automated, they require a support from all the OEM for various things. Actually, we are trying to focus on process adherence, quality cost control, the effectiveness of equipment use, and of course, sand. According to me, today whatever foundries are thinking about sand reclamation, they are thinking about a sand reclamation plant somewhere outside the foundry. According to me, there is a need of integration of sand plant, sand reclamation and sand source for the core. Basically, the sand plant manufacturer, rather Kunkelwagen kind of a company, they must look into providing a system, or some system must get generated that the sand plant, sand reclamation plant and a source for the core sand, they get integrated in the same foundry. Otherwise, the cost is going to be the prime factor. Cost and the quality are going to be the very prime factor for every foundry to, another thing is the export worthiness. Very few foundries are export worthy. The reason behind it is as Mr. Batutkar said, our scrap rates. Our scrap rates are quite high. What my foundry says, 6 to 7% scrap rate total, it is considered as a good scrap rate. It is no more good. If we want to think about a global foundry, we need to bring our scrap rate below 3% or in many places below 1%. 5,000 ppm at customer should be the target. 5,000 to 10,000 ppm at customer must be the target for all the foundry suppliers. And this only can happen by a quality improvement, creating a quality culture and looking at people and giving a proper training of the people or spending a lot of efforts on training of the people is very, very essential. Thank you.
Thank you, Mr. Bailey. I think there are one or two points that we need to consider as both suppliers of casting as well as users of casting. There is nothing like a defect-free casting. There is nothing like a defect-free casting. You go for quality level RT, radiographic level 1. RT level 1, what does it stand for? It stands for NSD. NSD stands for not a significant defect. The defect is there. It's not significant as far as the performance of the casting is concerned. But there are some jokers interpreting NSD as no single defect. And there was a person who used to cut the bloody casting slices, and if he saw some small spot somewhere, the whole lot of casting was rejected. Now, gentlemen, there are two risks which are involved. One is the customer's risk, which is the customer should not accept the rejected casting. And the other one is the producer's risk. The foundry should not reject unacceptable castings. So between these two risks, I am not in any way indicating or even suggesting that you should accept a bad casting. But I'm saying that we should develop standards, and there are companies, well-known companies. Let me name some of them. Mercedes, Scania, Hino, Dana, JSB, John Deere, Cummins. These are the people who have got acceptance standards, which have indicated level 1, 2, 3, 4, 5 for sand inclusion defects, slag defects, blowhole defects, crack defects, shrinkage defects, and certain, they have given the acceptance norms. Unfortunately, on most of our customers' end, the incoming inspector is the person who is not trained for doing the job. He has not been told what is to be accepted, what is to be done. He has not been told by his boss because his boss is more ignorant than him. And that poor guy, he cannot take a risk, even if he thinks so, because if his boss finds out that he has let the casting go, he will lose his job. And once that man takes a decision, his boss or his boss's boss or his boss's boss or up to the MD, nobody will reverse that decision. They are just scared of reversing the decision. So I think we need to work with the customers, and maybe when you get a new order for the first 100, 500, 5,000, 10,000 castings, the customer may not reveal his acceptance standards to you. But once he has built up his confidence about your capability, your consistency, your quality consciousness, perhaps he would share his acceptance criteria with you. I would very, very, very seriously urge you to consider talking to the customer, asking for the acceptance criteria. I don't want to accept a bad casting, but at the same time, I don't want to reject a good casting. That's my my take on it. Before we move ahead, let's ask our past president, IF, Mr. Sundaramurthy. Please contribute. You have heard a lot of deliberation. No, we'll do that thing, but...
We'll give aluminum its due.
Okay. Well, yeah. And not to take it away from you, Mr. Joshi. Yeah, aluminum, or in case your company is thinking about magnesium, please enlighten us.